Hello guys, welcome back to what I think is going to be the last video in our schematic section of the OrCAD X keyboard series. My name is Adam, and in this video we are going to cover the LCD portion of our keyboard. So I did, in between these videos, fix the footprint issue that I had with this component here. It was U2 before, it's U5 now. We'll go ahead and actually fix that, the reference designators at the end before we do all of our net listing. Now the LCD page is going to consist of two main components, and I've said it probably a million times throughout this video series, but it's going to have an I²C I/O expander as well as the actual LCD module. So let's go ahead and start with the I²C module. So that's PCF8574. And this component is pretty easy to use. So you've got power, ground, you've got your I²C interface, and then you've got all of the I/O, which is going to be toggled by, the data coming in through I²C, as well as these three pins, which you can use to change the address of, this I²C device if you so need to. So let's go ahead and grab some power symbols here. So we need our 3.3 volts. We need a ground symbol. Whoopsie. There we go. Ground symbol, 3.3 volts. Let's copy those to LCD page. So ground is going to VSS. And 3.3 volts on the VDD pin. There we go. We also want to add a decoupling capacitor. It's great to be in the habit of adding decoupling capacitors for all of your integrated circuits. So we'll place that, mirror it, slots in very nicely between these pins. It's almost like I planned it. And then we have our SDA and SCL lines. Now, SDA, or the data, and the SCL, the clock lines, these are pretty simple to use. Basically, they'll just connect directly to our microcontroller. I need to double check which pins are I²C compatible, but all they really need is just a pull-up, and the value of that pull-up is usually in the range of, I've seen anywhere from 5K to 10K. There are specific equations that you can use to calculate the value of your pull-ups based on, for example, your bus capacitance, how fast you're planning on running these, how long your I²C lines are going to be. But because ours is going to be very short, it's actually running pretty slow. And I'm so used to just dropping down 10Ks. That's what we're going to do, is we're going to use 10 kilo ohm resistors here as our pull-ups. And you want to make sure that they're pulled up to the same level as, the power supply of the device and the logic signals that you're expecting on the controller, or the level of the logic signals that you're expecting on the controller. So there's our pull-ups. Let's go ahead and add some off-page connectors here. These are going to be our SDA and SCL lines. Oops. SDA, SCL. And this side is pretty much good to go. Now let me just bring up the data sheet for PCF8574. I have this on my other screen right now, but I'll bring it into view in just 1 second. What I want to check here is, I know I don't want to use this interrupt. And if I look at the data sheet, let's just take a look here. So it looks like A0, 1, and 2 can be tied directly to ground rather than having to use a resistor. And then the interrupt is an interrupt output connect to VCC through a pull-up resistor. Yeah, looks like if we're not using it, we can just connect it to VCC through a pull-up resistor. However, I have also seen this used where it's just left unconnected. Yeah, so in this case, okay, it's saying that the interrupt should have a pull-up to VCC if it's connected to an interrupt pin on our microcontroller. But that's only if you're expecting data coming into the microcontroller. We're only outputting data from the microcontroller to the expander, then to our LCD board. So we're going to go ahead and leave this unconnected. Let's just see if there's any more information about the interrupt pin. So open drain output interrupt. Okay, so it's okay if we just leave it unconnected. Place no connect on the interrupt. And then we'll tie these 3 pins for selecting the I²C. For selecting the I²C address, we'll tie these directly to ground. All right, and then we basically have these 8 pins here, so P0 through 7, which are going to be our additional GPIOs, or in this case GPOs, because we're only really using them as outputs. We'll connect these to our LCD in a second. The one other thing I want to add really quickly is if we look at our device here, I like to add a little note for what the actual I²C address is. And if you're looking at a data sheet, sometimes it might be at the top. Other times I usually just do a Control F and look for the address. So it's going to be 0100A2 A1 A0. And if I remember my hex correctly, 0010, so that's 0, 1, 2, 4, so that's 4, and then our hex here, so that's 4, 1. So let's place a note. Place text address 0x41. And we'll leave that right there. And if for some reason I'm wrong, which it's very likely because I'm a little rusty. Actually, you know what? We can check that. Calculator. So if you're not familiar with the programmer function on your calculator, in programmer, you can just type in binary and it'll give you the hex. So we have 0100 and then 00. Oh, you know what? I am wrong because I picked this read-write bit as the last bit, but really it's just these 7 bits here. So it's 0100000. So our hex is actually 20. We should expect this to be on address 20. And if you're programming, you can always kind of double check by, if you have an I²C address, it's called an address sniffer. You can see what all the I²C devices connected to your I²C bus are. But it should be 20. All right, so the next thing we need to do is add our LCD. So it's NHD. This is an LCD from New Haven Display that I've used probably about 1 million times on a bunch of different projects. We're going to go ahead and hook this up here. So we're going to use P0. Actually, let's name each of these nets here. P0 is going to be our RS signal. Let's place all of these really quick and then we'll rename them. P1 is going to be our RW signal. P2 is enable. And then we have, I believe it's called BT. Yeah, this is going to be our backlight. And then P4 through 7, these are going to be our data. So we're going to be using data bits 4 through 7 on the actual LCD display. So D4, D5, D6, and D7. Now let's just go ahead and wire these. So I'm going to make it such that D7 just gets directly connected to where it needs to be. And then D6 should also just go directly across. D5, D4. Backlight is going to be down here. We'll connect that with a MOSFET in a second. Our enable should go to the E pin. Our read write will go to the read write pin, aptly named, and RS to the RS pin. There we go. All right, so the LCD will run directly off of our USB power. So we'll drop this 5-volt power here, and we'll connect that to the LED plus, which is going to be the supply for our backlight, and also this VDD. And then VSS is going to be our ground connection. So bring this down all the way over here. And you'll see why in just a second. Then D0, 1, 2, and 3, we're going to leave those unconnected. And that's because you can actually choose if you want to drive this serial interface for the display with either 4 bits or 8 bits. And if you're just doing 4, you actually use the last 4 bits. So place, no connect, 1, 2, 3, 4. All right, and then our V0, this is actually the adjustment for the contrast on our LCD. So we need to go into our Component Explorer and look for a potentiometer. Now what this potentiometer will do is basically provide us a variable voltage for that backlight, and then you can turn the potentiometer to adjust the contrast on your LCD. And this is also going to go to ground. But this wiper here is going to go to our V0. And then, of course, pin 1 will go to power. And then last but not least, let's go ahead and borrow this MOSFET from our LCD page. And we're going to drop it right here, such that it syncs the current from our LED backlight to ground when turned on. The only thing that I want to add here, because I don't remember if these are capable of pulling down to low, or if they're actually, you know what, we can check that. We have the technology to check that. So peripheral devices, outputs, let's look at our pins, push-pull design structure. So we shouldn't need a pull down on this MOSFET. However, one thing that I would recommend is you kind of consider how you want your startup conditions to look like. So when you first apply power to this chip, does it toggle all of the outputs to high? Does it toggle them all to low? You might not know that. So in this case, I would still recommend putting a pull down here so that this doesn't float. Actually, in a push-pull configuration, it should still be fine. I'm just so used to including the pull down that we're going to do it anyways. So we're going to go ahead and save that. And let me see if there's anything else that we're missing. Ah, yes. So these mounting pins on the LCD, these are non-conductive. They're just mechanical holes. So we'll go ahead and just place our no connects here. These do not need to be connected to ground. Let's try that again. There we go. And I think that just about covers it for our LCD page. So let's go ahead and connect these SDA and SCL signals to our controller. And I think we're pretty much good to go. I don't see any warnings in my DRC, which is always a good sign. One thing I'm going to do off stream really quick is I'm just going to double check on each of these pins to make sure that, you know, this GPIO 26 and 27 are actually compatible with running my I²C interface. But otherwise, everything else should just be your general GPIO. The rows and columns are either going to be toggled high or low, or will be configured as an input and reading either high or low. And then the LED data is just a simple digital signal output. And a GPIO pin should be able to handle that. And then finally, yeah, like I said, so I'll double check SDA SCL. I'll do a quick couple double checks on the schematic just to make sure that I'm not missing anything. Maybe I missed a decoupling capacitor. And I recommend that if you are creating your own schematic as well, always double check, triple check. If you have a friend or if you have a colleague, get a second opinion on your schematic just to see if you missed anything. And then we'll go from there. We will netlist into the PCB and start on our layout. All right, guys, thank you for watching this video. Hope you enjoyed it. And if you have any questions or comments, please leave them below. And I will see you in the next video where we'll go ahead and get started with placement for our board. So it's pretty exciting and hope to see you there. All right, thanks, bye.